In case you want to do a little review of Rolle's theorem and mean value theorem. So here's an example that I just made up for Rolle's theorem. So let's look at this. Let's look at this function here, and you know, if you look at it, you notice that it's got a couple of roots. So it's got a root at 0, and actually it's a double root at 0, and it also the whole thing is equal to 0 if x equals -4. So if we make x equal to -4, there'll be another root. This turns out to be, of course, a cubic equation, so it's -x cubed minus 4x squared. Because it's negative, it's going to go down first and then up, so it'll go something like this. You know, as usually we go down or up and then down. But this function, because of the negative in front, is going to come the other way. So it's going to start over at positive infinity when x is negative, and end over here at negative infinity when x is positive. So it'll look something like that. So right here, the slope between, you know, in the interval -4 to 0, the slope there is going to be 0. So we should be able to find, by Rolle's theorem, a point between -4 and 0, where the slope of the function will also equal 0. So that's what Rolle's theorem says. So it kind of, what we have really is we've got something like this. We've got a function that comes down, comes back up, and just touches the origin there, and then goes down. So between this point and this point, the slope is 0. So Rolle's theorem says that there's got to be another point between there if the function is continuous and its derivative is defined, where the slope will also be 0. So we want to find that point. Okay? So it's on the interval from -4 to 0, and we want to find the point between there where the slope, the first derivative, is equal to 0. So we differentiate this, so f prime is going to be -3x squared minus 8x, and we make that derivative equal to 0, and then we solve for x. So I'm going to solve for x by factoring out a -x, and that'll leave me +3x plus 8 equals 0. So this first derivative is going to equal 0 either where x is equal to 0, which of course is right here, and that's not the point we're looking for, or where this other parentheses is equal to 0, so that's where 3x plus 8 would equal 0. And of course that's going to occur where 3x equals -8 or x equals -8/3. So right here at -8/3 is where the first derivative is going to equal 0. So there f prime equals 0. And of course we should check that by taking that -8/3 and putting it back into this equation and verifying that it really does equal 0 at that point. So I'll do that. Let's do that. F prime, where for -8/3 is going to be -3 times -8/3 squared minus 8 times -8/3. And we can do that on our calculator. So let's just check that out. So just put it right into your calculator like that, parentheses, -8 divided by 3, close parentheses, square that, minus 8 times -8 divided by 3. And that turns out to be 0, so that's a good check. So that's Rolle's theorem. Any place on a continuous function where the slope between 2 points is 0, there has to be a point between that where the slope is 0 also, where the first derivative will equal 0. And of course the first derivative has to exist on the open interval between those 2 points. So that's Rolle's theorem.